Hey guys, so some of these rotational questions will ask you to find the ratio of one type of energy over the other. So I want to show you how to do one of these. So here we have a solid cylinder. Solid cylinder tells us that we're supposed to use I equals half mr squared of mass m and r. So it's not actually giving us the numbers. This is going to be a literal question or just with letters, variables. It rolls without slipping on a horizontal surface. This is called rolling motion. And it means I can use this equation. VCM equals R omega. Okay? Because it's rolling like this. So VCM is tied to omega. All right. I want to know the ratio of its rotational kinetic to its total kinetic energy. So what you do is you follow what's saying here and you set up a ratio like this. So it's saying rotational kinetic energy. So we're going to write K rotational, that's the top, to total kinetic energy, that's the bottom. So ratio of top to bottom, K total, which is K linear plus K rotational. And now what we're going to do is we're going to expand these equations as much as possible. What I mean by expanding is, well, what does KR stand for? KR stands for half I omega squared. KL is half mv squared, and KR is half I omega squared. And we're going to expand this as much as possible, meaning we're not going to stop there. We can replace I with this right here. Let's do another color. I can replace I with this, right? And I can also replace omega with something else. The problem here is I have V's and omegas. There's too many variables. Whenever you have a V and an omega, you usually want to replace one into the other. So V equals R omega. And what we're going to do is whenever we have V or omega, whenever we have V and omega, we want to get the omega to become a V. Okay? So I'm going to write omega is V over R, and we're going to replace this here. The reason we do this is so that we have fewer variables, so it's easier to solve this question. Now before I start plugging stuff in, I want to warn you, you cannot cancel this with this, right? That's not a thing. So don't get tempted to do that. What you can do is you can cancel the halves over here because they exist in all three of these guys here, okay? So you can cancel the halves, and this simplifies it a little bit. So what we're going to do now is expand I. I is going to become half. It's the half from here, not this half. That half is already gone. So it's the one inside of the I, mr squared. And remember, we're going to rewrite W as V over R. And then this whole thing is squared. Now we're going to do the same thing at the bottom. But before I do that, you might notice right away that this R cancels. Right? So that's another benefit of doing this thing here. Another benefit of doing this thing here is that it's going to cause the R's to cancel. Okay, so at the bottom I have simply mv squared plus I, which is half mr squared, and then omega, which is V over R squared. And again, just like it did at the top, the R's cancel. Okay, the R's cancel. Let's clean this up a little bit and see what we end up with. I end up with half mv squared divided by mv squared plus half mv squared. And you may already see where this is going. There's an m in all three of these, and there's a v in all three of these, so everything goes away, and you end up with just some numbers left here. So you have half up here, and then there's a 1 here, right, that stays there, 1 plus half. So the mass doesn't matter, the volume doesn't matter. I'm sorry, the mass or velocity, not volume, they don't matter. So all you have to do is do this thing here, okay? There's two ways you can do this. If you like fractions, you can do it with fractions. I'm going to do that first. So I'm going to rewrite this as a 2 over 2. And then I have 1 over 2 divided by, I got a 2 at the bottom here. And then I can add up the top here. So it's 2 plus 1, 3. So I have 1 over 2 divided by 3 over 2. I can cancel this 2. And then I end up with 1 over 3. If you don't like fractions, one thing you can do with this particular case is you can rewrite this like this, or half is 0.5. This is a 1. This is a 0.5, right? This is better, maybe if you have a calculator. 0.5 divided by 1.5, and if you do this in the calculator, it's 0.333. which is the same thing as this, okay? Same. So that's it. The ratio is 1/3. And by the way, that ratio will change if you have a different eye, because this half here ends up showing up here and here, or actually that half ends up showing up here and here, right? So if you have a different shape, this will be a different fraction, and then your final answer will be different. So the ratios change depending on what kind of shape you have. All right, that's it for this one. Let me know if you got any questions.